Newton's second law, the acceleration of an object is directly proportional to the net force, inverse proportional to its mass. We can express this mathematically as follows. A Newton is defined as the force that produces an acceleration of 1 meter per second squared when acting on a 1 kilo mass. 1 Newton equals 1 kilogram 1 meter per second squared. 1 Newton 1 kilogram 1 meter per second squared. Free body diagram. A free body diagram shows all external forces acting on an object, and drawing a free body diagram is an important step in applying Newton's laws. First, we assume that object behaves as particles, so that we need not worry about rotational motion. Second, when we apply Newton's first or second law to an object, we are interested only in the external forces acting on the object because internal forces do not affect its motion. For example, an electric fan mounted on a boat and blowing on its own sail cannot move the boat, and a human arm cannot pull on its own body. Third, the words lightweight, negligible mass are used to indicate that the mass of an object can be ignored. Internal forces and external forces. The term system refers to the object we are interested in analyzing. Internal forces are exerted by objects within the system, whereas external forces are exerted by objects outside the system. The surroundings are everything except the system. For example, there are particles A, B, and C. Other system include only particles A and B. The system includes only particles A and B. The force exerted by particle B on particle A. Internal force. Whereas the force exerted by particle C on particle A is an external force. Tension. When a rope attached to an object is pulling on the object, the rope exerts a force on the object through the rope. The magnitude of this force is called the tension in the rope. Tension in the rope, and is denoted by the symbol T. The magnitude of the tension is the same at every point along an ideal rope, which means that the force applied through the rope is transmitted completely to the object, and that the tension is independent of the length of the rope. Rope, object, rope, object rope T T T T T prime T prime T prime T double prime T double prime. The direction of the tension force exerted on the object is along the rope and away from the object. Away from the object. Away from the object. Away from the object. T prime, T2 prime. Normal force. The normal force is the contact force exerted by a surface on an object in the direction normal to the surface. The direction of the normal force is from the surface towards the object. Surface, particle, object, and vector, perpendicular, normal force. The magnitude of the normal force is often equal to the magnitude of the gravitational force, but we should note that this is not always the case. And perpendicular. And perpendicular. And perpendicular. Newton's third law. If two objects interact, the force F12 exerted by object 1 on object 2 is equal in magnitude and opposite in direction to the force F21 negative exerted by object 2 on object 1. Newton's third law. Particle 1, particle 2, F1, 2, F2, 1. Newton's third law states that a force that affects the motion of an object must come from a second object. This is equivalent to stating that a single isolated force cannot exist. The force that object 1 exerts on object 2 is sometimes called the action force, while the force object 2 exerts on object 1 is called the reaction force. Action force F21, reaction force F12. For example, the force acting on a free-falling projectile is FEP. FEP equals mg, which is the force of gravity exerted by the Earth on the projectile. The reaction to this force is the force exerted by the projectile on the earth equals negative. As this example shows, we identify the action and reaction forces simply by exchanging the object exerts the force and the object the force is exerted on. For example, consider a TV at rest on a table that is at rest on the earth. The earth, the table, the TV. Because the objects are at rest and in equilibrium, Newton's first law should be applied to them. Let's identify the action-reaction pairs. Because there are three objects, there are three interaction pairs, the TV and the table and the earth, and the earth and the TV. Note that for four objects, the number of interaction pairs is given by 4 combination 2, which equals 6. Before doing this, we indicate all the forces acting on the object in the figure. First, let's consider the TV of mass m and the earth, FME. Is the force exerted by the TV on the earth, FEM. FEM is the force exerted by the earth on the TV and is the gravitational force, mg. By applying Newton's third law, we obtain the following equation: Fme equals negative Fem. Next, let's consider a TV and a table, FMT. FMT is the force exerted by the TV on the table. FTM FTM is the force exerted by the table on the TV and is the normal force N. Therefore, FMT equals negative Tm. FTM. Finally, let's consider a table of mass mt and the earth. FTE FTE is the force exerted by the table on the earth. FET FET is the force exerted by the earth on the table and is the gravitational force for the table mtg. mtg. Therefore, F te equals negative f et. Third law, Newton's third law. By simply exchanging the subscript of the action force, we obtain the reaction force. Please note the following. Until now, we have applied Newton's third law to interactions involving two objects at a time. However, Newton's first and second laws should be applied to one object at a time. For example, let's apply Newton's first law to the TV. The TV is the system, and the earth and the table are the surroundings. The external forces needed to determine the net force are the forces exerted by the earth and the table. That is F equals mg Ftm equals n. Let's write Newton's first law for the table. Positive Ftm, negative Fem equals 0. Positive n, negative mg equals 0. Example D1. Hockey-puck A. Determine both the magnitude and the direction of the puck's acceleration. X-axis, Y-axis, puck, M, F1, 세라 1, F2, 세라 2, F1 코사인 세라 1, F1 사인 세라 1, F2 코사인 세라 2, F2 사인 세라 2. 2D problem 1D plus 1D. fx equals f1x positive f2x equals f1 cosine theta 1 positive f2 cosine theta 2 positive fy equals positive f1 sin theta 1 negative f2 sin theta 2 fx equals 4 times the square root of 3 over 2 positive 8 the square root 3 over 2 equals 6 the square root 3 Newton positive I Fy equals 4 times 1 over 2 negative A times 1 over 2 equals negative 2 Newton negative J. Ax equals Fx over m equals 6 the square root of 3 0.2 30 root 3 Newton positive I. Ay equals Fy over m equals 2 over 0.2 equals 10 Newton negative J. Therefore, A equals 33 I negative 10 J Newton. Because the x and y components of the acceleration are perpendicular to each other, the magnitude of the acceleration can be obtained using the Pythagorean theorem. A equals root ax squared plus ay squared equal the square root of 30 root 3 squared plus 10 squared equals 10, 10, 10, the square root 27 positive 1. 28 equals 4 times 7 equals 20 the square root of 7 meter per sec squared. The direction of the acceleration can be obtained using the tangent function. Tangent theta equals ay over ax equals 10 over 30 square root of 3 equals square root of 3, 9. Therefore, theta is approximately equal to 10.9 degrees. B. Determined if the components of a third force that caused it to have zero acceleration. Fx equals 3I Fy equals 2 Newton negative J. Fx 3x positive Fx equals 0 f3y 네거티브 fy equals 0 f3x equals negative fx equals negative 6 square root 3 Newton I had f3y equals positive fy equals positive 2 Newton j f3 equals negative 6 root 3 I 2 j Newton